Okay, so we are now moving on to 2A, and what we're doing in 2A is we're doing law of science, but we're doing the ambiguous case. So we're keeping it in the law of science family, but it says the following make two triangles, which definitely cues our brain to think that. So if I look at this first one, you'll notice we have a complete pair. We have C and C. And we are going to start off by finding out what is angle A. So here we go. We're going to do some law of science because we've got the pair. We've got angle C is 25, side C is 10, angle A, side A. So we get 10 times sine A equals 20 times sine 25. And when we do that, then we're going to end up dividing by 10. So I'm going to do 20 sine 25. So far, so good. And then I'm going to divide that by the 10. And then I'm going to get that sine A is approximately 0.84523652348 Okay? And whoops. We are going to, let's see. We are going to do now sine inverse of that particular situation. And we're going to get A equals 57.7 degrees. Now it tells me it makes two triangles, but honestly, whenever you see sine inverse, your brain should go, uh-oh, could it be two triangles? Am I doing two triangles? So I'm going to check the second version of A, right? And so I'm going to do 180, and I'm going to subtract 57.7. And my second version of A is going to be 122.3, which in the context of this question, having a 122.3 degree angle and a 25 degree angle is totally fine. Okay, so then we have to finish solving the triangle. We've done C, that was in the original. We've done A, so now we're going to do B. In order to do B, I'm going to divide my paper, quote unquote, in half. I'm going to divide my paper, quote unquote, in half. And what I'm going to do now is I'm going to attack the one side of the problem first. So essentially, I could call it A1 and A2. You don't have to if your work's organized, right? If your work's nice and organized and I can see which one's which, great. But if not, you might want to make sure you do this part. So I'm going to start on the first side, the one with the ones. And B1 comes from 180 minus the 25 that I started with, minus 57.7. And that leaves B1. In other words, if I use just the normal acute angle for A, and obviously C as I started off with, I'm going to get a 97.3 degree angle. Whoops, got a little glitchy right there. Sorry, let's try that again. A 97.3 degree angle. And then I can finish now by finding out what will the side be for B1. So I'm going to come back to sine 25 over 10. We're just grinding on the law of science here. Sine 97.3 over B1, right? So I'm looking at baby B here. And if I cross multiply and divide here, so 10 times sine 97.3, right? Those two would be multiplying on one side of the cross multiply. 10 times sine 97.3 equals B1 sine 25. So then in the whole process of solving this question, we would divide by sine 25. And B1, oh goodness, B1 will be 23.47. Okay, so that's one version of this problem. The other version of the problem is when we had an obtuse angle for A, and we can keep going this problem. So B2 will be 180 minus our 25-degree angle minus 122.3. So here we go. So we've got 180 degrees in every triangle. We've got a 25-degree angle. That was the C that was given to us in the very beginning of this problem, right? That's where this 25 is coming from. So that's angle C. And then 57.7 is the angle A1, or in the problem we're doing right now, it's the angle A2. So just that's, if you're wondering, like, wait a minute, where is she getting these numbers? They're just part of the problem. They're just different parts of the problem, depending on where we're at. So in where we are right now, B2 is 32.7 degrees. And then we can finish this by solving for the side that matches up with a 32.7 degree angle. So 10 sine 32.7 divided by sine 25, and B2 is 12.78. Which makes sense because a 32 degree angle is a little bit bigger than 25. 12.78 is a little bit bigger than 10. So that is the two parts to this one. The next one also has two parts. Let's check this out. So we've got angle C, side C, and we've got A, the side that we know, and A, the angle we're about to know. So sine 33 over 6 equals sine A over 10. So we're going to cross multiply, divide. Sine A equals 10 sine 33, close my parentheses, divided by 6, 0.9077. And you know, we've talked a lot about like storing more information in our calculator by using that answer button, right? And giving yourself maybe a couple more decimal places. And trying to make sure we like really get after it. Just improves your accuracy. It's not anything too crazy. Like we're not going too worried about it, but it is something that, I don't know, it's a good habit. Anyway, that was me rambling. This is a 65.2 degree angle. Sorry. Now, again, the question told us we had two choices, but whenever we do inverse sine, we're going to want to make sure we've just checked both choices. So for A2, in other words, what could the other angle be? Let me try that again. What could the other angle's measure be if we do 180 and think about this in terms of an obtuse answer? So we do 180 minus 65.2. And we get 114.8, and that is totally fine to have as an answer as we keep going forward. So here we go. Now I'm going to find angle B. 180 minus the 33 minus 65.2. I get 81.8. And then I go sine 33 over 6, right? That's that orange pair from the very beginning of the question. I just love reusing it. I don't know why. It's exciting to me. 6 sine 81.8, closing my parentheses, divided by the sine of 33. And B1 is 10.9. We want to go through and check it. B1 is almost 11 for an 82 degree angle. The 65 degree angle has a measure of 10, and the 33 degree angle has a measure of 6, which is super cool. That means that it all sort of lines up the way it's supposed to, right? Using our Goldilocks theorem of the biggest angle better get the biggest side, and Papa Bear better get the most porridge, just in math terms. Okay, so just really quickly, I'm going to attack the second part of this question because it does say solve. It says make sure we get all the values because we're not bums here. We want to really lock it down and do a good job of what we're trying to make happen here. So B2 is 32.7 degrees. And then we can set it up. Now, I'm going to write this and then I'm going to pause for a second. This is really cool to me. And I realize I'm weird. I get that. But if I have a 33 degree angle and the side associated with that, right? So that 33 matched up with a side of 6. My 32.7 degree angle better be real close to 6. So let's check it out. 6 sine 32.7 divided by sine 33. And we get 5.95. So cool. I love it. And that makes sense. It's a little bit smaller than 6 because 32.7 is a little bit smaller than 33. But it's super close and super cool. So definitely the toughest questions. Make sure you ask if you get stuck.